view because I'm going to share my own experiences and opinionated view about building an API at Savings. I'm going to address some technical choices we've made and why we've made them and what we think about it. So for who is this talk? Yeah, for people and engineers who like to know more about this technology, so Kotlin, I will tell a bit about coroutines and the arrow library we used and how to connect with the Oracle database. But I think it's also interesting for everyone else that likes to know a bit of experiences with building a real-world application at this bank. So something about me, my name is Arno Beljaars. I'm an engineer at the daily banking tribe Savings. And here you see a recent picture of most of our team. And this was at a farewell party of one of our colleagues, Daan Vonk, as he retired after 43 years of loyal service to our company. Don't think there are much of us that can say the same. Not everybody is in this picture, notably Arthur is missing and Rob as well, although they did a lot for this API, so that's a pity. And as you can see on this picture, that it's in the Spanish team, and that's because Daan was migrating to Spain. Personally, I don't have much with Spain. I'm a typically Dutch guy. I grew up in Brabant. I now live in Gouda, the city famous for its Dutch cheese. And I often cycle to the office, even from Gouda to Amsterdam, like this morning. So it doesn't get more Dutch than this, I think. I don't have a background really as a developer in Java or Kotlin. I worked at different roles in my past. I started as a Microsoft consultant, worked with C# development. But then when I became an internal like 5 years ago at ING, I switched to the JVM stack. And the project I'm now telling about is my first Kotlin project. So which API I'm talking about? Well, it's a famous or infamous Savings Inquiry API. And basically that's an API that is answering questions like, give me all your savings accounts related to this person, or give me all savings accounts related to this current account, or give me all the details of this specific savings account. And it's used in the different channels, like Ming, your mobile app, and also the assisted app. And you know that this API is working when you open your ING app and you see your savings accounts. And it's just to tell you that this is an important API, and we often feel that importance, especially when the app is not working and not showing your savings details. Then you get a very special feeling of importance. Sorry? It's not screen. Oh. There goes my time. Yeah, here's sharing the screen. So yeah, I was just telling it's an important API, and we know that feeling of importance when it's not working, and then we get that special feeling, sometimes called stress. But luckily, it doesn't happen too often. So why do we rebuild it? Because we already had this API, right? And I don't want to discard anything from the previous developers because they were very, very smart people, and they built an excellent API that served our company for many years. But we needed to move to Target. So that was an architectural decision. A lot of ING colleagues know that we needed to move from Riaf to Mirak. But there were also other considerations, yeah, like our old APIs used a lot of TIBCO connections. And TIBCO was considered also not Target anymore. But there was also a data reason because we used a lot of profile identifiers and we needed to move to other identifiers in one PAM. And when we just knew that we needed to change this API and basically rebuild it because the design completely changed, we were also thinking about other non-functionals like scalability, maintainability, and in the end also developer productivity. And then Kotlin came into the picture. So looking a bit at the old API, just to make a comparison with the new API. Our old API was mainly built in Java and Scala. And that is very powerful and very fast. But my point is that I'm trying to make it's not always accessible. And there was a bit of blocking I/O. I will get to that later. Because the old legacy API used a lot of Twitter Finagle. And the Twitter Finagle was used for the connection with other APIs. But that also meant that in the code there was a lot of converting of objects to the Scala and Java futures. And what you get is that you get a lot of fast processing, like also Scala supports this asynchronous programming and functional programming. But what we saw in code is that all these converted objects were passed along to the methods. Just like you have in functional programming, that you can consider a function as a first-class citizen of your programming language. So you can use the function as an input for another function. Kind of chaining, and this is also called as a heavily callback based. But when it gets big in a program, it can lead to what's also called callback hell. And I would argue that is not very maintainable then anymore. And also because Scala uses quite some custom abstractions, and it has a heavy use of implicits with the use of Twitter Finagle, for instance, action and also of properties. This is just, I don't think you can read everything. It's also not the purpose of this slide, but just to give you an impression about how the old code looked like. Here you see just one method that I needed to change because one of the identifiers in a method changed. And for me and also my colleague, it was not directly obvious where I needed to change this. Yes, some of you might think, well, then you just need to be a better programmer. Yeah, I point taken. I get that. But that's not the world where I live in. There's already a lot of things we need to learn. There's a high cognitive overload. So I like to keep it as simple as possible. And in my opinion, this was not as simple as possible. One of the things, there were some abstractions going on, also implicit functions from other places were injected into this code. And it's not sequential. So to understand what's going on, I needed to read everything and start it basically at the bottom, because we have a list of arrangements, and the list is traversed, and for each of agreements, sorry, and for each agreement, the account holders were fetched, and then from this list of account holders, the names were fetched. And here, and then you get to these account holders method with def. There I needed to change some identifier. It is not about the details, but this is just to show you that it can become quite complex for a not that skilled Scala developer. A simpler example here. Here you see at the top, you see the Scala example. At the bottom, the way of programming we choose in the new API. And in my opinion, the new way is a better way, but we can argue about that. And at the top, you see the Scala way with the nested approach. So you see that flat maps are used and maps are used to unwrap these boxes. And below you see the coroutine way. It's nicely sequential, and you can read it from top to bottom. I read some analogy is that the Scala way is a bit like reading sentences that are hidden in boxes. And when you want to read everything, you need to unwrap each box so you can read everything. And the Kotlin way is more that each sentence is nicely written on one page. So you don't need to unwrap anything. So why is this important? Yeah, in my opinion, Kotlin is much easier to follow. It looks like sequential code, and it's also for the error handling and the debugging purposes. Because it's all nicely integrated. And you don't have all these implicits like Scala has. So we have less magic, less surprises. Similar to Ktor, probably. Yeah, it will always get some complexity anyway. But do we lose all functional programming then? No, but we decided, or the ones who started this new project, we added also the Arrow library. And for those of you who don't know, Arrow it's a library that offers additional capabilities next to the Kotlin standard library, especially for functional programming concepts. We choose a few of them, like Arrow for handling either for handling errors, and validation and accumulation of errors. And then we need to be careful that not the same trade-offs occur as what we just saw with Scala. But here is as a basic example I often saw before at other conferences where someone who was very enthusiastic about Arrow showed these kind of examples. It's not exactly the same, but this is the concept. So here we do some validations on amount and currency. And when everything goes well, we return the balance. And if some error occur or multiple errors occur, we return that in the left-hand side in the validation errors. And this looks very nice, right? It's a very clean way to check for errors and you can use it in all kinds of data classes. But in our practice, it became something like this. And yeah, if you can see it, to me, it looks rather ugly. And when it's ugly, it can get bugly with bugs and ugly. So, and this is because the zip or accumulate has a maximum limit. If I remember correctly, it was 10. And when you reach, or even 8, and if you reach that maximum, you need to do something. You need to start working with pairs or tuples to grab these objects. And then it gets quite complex. So I didn't like this in particular. Another disadvantage, I don't have a slide for that, is that when you use a lot of iders, you need to propagate it when you want to do something with the results. So we started using arrays, and Rob has a big influence on that, and we are thankful for him, because this makes our code easier, and it separates the error handling from the business logic. And here we use the arrays client failure with a context receiver, and basically means that you need this context for your function to be able to be called. And it leads to cleaner code because you don't need to unwrap all these results in the iders. Here you see that in action in a simple example. The top one is without this context receiver, and you want to do something with the exceptions. So again, all these flat maps occur, right? You get a nested structure. And in the below example, where you use this context receiver with race, you avoid that nested structure. And again, it's easier to read and comprehend what's going on. And this is a small example, but the bigger that code gets, the more important this becomes. So our lessons with Arrow is a nice library. It gives additional functional capabilities, but don't overdo it. Don't use it for all validations and error handling. And when you use iders, also consider switching to the context receivers with race, because it leads to cleaner code and it's easier to read. Well, we used coroutines and Arrow for the input validation when we called other APIs, but we didn't only call APIs, we also used local of our own database. And we went into production because the database was very simple. We only had say 2 tables. It was an Oracle relational database. And the data in the database was optional for us. There was goal-related data. And if the data was not there, it was not the end of the world. The API could just continue. So we had some error handling in that if we didn't get the data, we would just continue. We thought everything was fine. But we did a DR exercise luckily in the service window. And we saw this in our monitoring, that it didn't went as well as we expected. So we saw some errors. And we thought, hey, how could it be? So in the next few slides, I will show you a few things we improved upon, and some things also we are still thinking about how to improve. Sorry? Some learnings, yes. One of them is, well, it should not be an issue for us. Why? Because Oracle comes to the rescue. Oracle DBAS, we have database as a service here at ING. And for normal databases that are deployed, and we have multiple data centers in place, you can see that if it's configured correctly, then you see that this auto value is stored over here. And that means that transparent application continuity is enabled. And basically that means that if one data center is not available, Oracle takes care of it, that your connection will switch to the other data center. At the application level, you don't need to do anything for it, except that you need to configure it correctly. So you need to configure it in your connection string. And one of the things that is especially important, and I want to give it as a tip over here, is that you especially need to look at your transport connect timeout settings. Because if I remember correctly, the default setting was 30 seconds, and that is awfully long, especially when you expect your API to return a result within 2, well, max 3 seconds. So we fine-tuned it to a way lower setting. The other thing, and that's an interesting topic, also yesterday we discussed it, is the choice of the library you use to connect to the database. And most of our APIs at ING use the OGDBC library. But I followed a course by Urs Peter, who also did some talk here today. And he said during that course, well, if you have a coroutine-based API, you should not use JDBC, you should use R2DBC. Why? Well, that's because R2DBC is a non-blocking library. And GDBC is a blocking library. And blocking, that means that you use your thread to connect to the database, and then basically your thread waits for an answer from the database. It's not what you want in a high-performing application. So yeah, we were thinking about it. I was also thinking about a lot. Okay, should we switch to that new library, right, at R2DBC? But there are a lot of cons as well for this. One of the most important one is not that established library in the world, but especially also not at ING. I searched the repos, and not as intently as Julian, but I only found one example of a production implementation of this library. So we don't have that much experience with it. Then I searched for some other disadvantages, and that is one of it, you need to do some kind of changes, but that's doable. But the most important part is that fallback scenario, that high availability support that Oracle offers is not supported with this library. So what do you do then? Well, you're testing, of course, Captain Obvious, but you also need to do those changes. And one possibility is that you use your own circuit breaker library. So that means that if you call one database at a data center and that fails, that you say, okay, I try it with another connection to the other data center. And if that also fails, in our case, because the data is optional, we could do a graceful degradation and just ignore the error. But this shows that you need to do something. And with a library for a certain with a certain circuit breaker library like Resilience4j, that is more often used within ING, that you can configure those settings, like the number of retries, the amount of seconds that you wait for a response, things like that. Yeah. So this is another example you need to do in code changes with R2DBC. Like JPA offers all kinds of annotations that automatically maps data. In R2DBC, you need to do it yourself manually. So you need to grab an identifier and search the related code. So we're still thinking about it. Should we do this or not? We are in the testing phase. But one thing you definitely should look at, if you did not do it already, is look at the dispatcher that you use. Because dispatchers are used for like a traffic controller. It says like which thread should be used for a certain coroutine. Should you use the main thread, or should you use a background thread, or a different thread pool? And what we did when we built the API is we used the default dispatcher, but that one is not intended for I/O intensive tasks, like calling other APIs or calling a database. It's more intended for CPU intensive tasks. So you need to switch, if you have the kind of operations we do, to the dispatcher.io. One thing to think about when you do that, and we forgot it at first, is that you need to take a close look at the tracing chain. And we use tracing or OpenTelemetry for the logging information, that one API calls the next, and then we call the downstreams and how that goes in the flow. But if you need to do something specific, because this tracing chain get broken if you switch the dispatcher and don't do this small trick. So when you switch the dispatchers, you need to explicitly add the new tracing context to your current context. And you could also add things like MDC context for the logging to that. And with this trick, you maintain your tracing chain. So to summarize, I told you a bit about our technology use. I gave a few highlights, like coroutines. In my opinion, it helped us in making a better maintainable API. We use some features from the error library. yeah, we needed to improve the way we connect to the database, like transparent, high availability. We are still considering the database library, and we're improving the dispatches and how that works with tracing. But yeah, the most important part was that at the end we accomplished our mission, and I copied a screenshot from Sumit in the back that he was very happy as our manager that we brought this live, especially before the May peak, because I don't know if you know it, but end of May a lot of people in the Netherlands are frenetically hitting the F5 button to see if they got their holiday allowance in time, and that impacts our API because we get a lot of more traffic. But everything went well. We could easily handle like 1500 TPS, no incidents. So we were very, especially myself, very relieved with that. A good success. So with that, I come to the end of my talk, and I have only one thing to say to you, and that's thank you.